All right. So we are going to really quickly go through using proportional reasoning to solve problems. We should already be finishing 2 lessons this week, one on proportional relationships in tables and graphs, and then one on using proportions to solve problems. The first example that we're going to look at are ratios. A ratio is something that compares 2 or more things. So for example, boys to girls, or yellow to red. So if we have a bag of 24 marbles and 16 of them are blue, what is the ratio of the blue marbles to the not blue marble? So if all of them, our total is 24, and 16 of those are blue, how many of them are not blue?
8.
Good.
Took me a second.
So then the ratio of blue, which is 16, to not blue would be 16 to 8. Because when we write ratios, order matters. Now I see that both of these numbers are divisible by 8. So I can divide by 8.
Every 2 blue marbles is 1 not blue.
Exactly. So for every 2 blue marbles, there is 1 that is not blue.
Yes.
Cool.
Great. So now we're going to do a second one. So if we have a box of 17 pencils and 9 of them are sharpened, so now our total is 17, and 9 of them are sharpened. What is the ratio of unsharpened to sharpened? So again, notice order matters. So if out of 17 total, 9 are sharpened, how many were not sharpened?
8.
Good. So then if we want to write the ratio of unsharpened to sharpened, what would that ratio be?
9 sharpened to 8 unsharpened.
Ooh, let's think. The 9 is
9 unsharpened to 8 sharpened. Or is it
8.
I don't even know.
So how many were unsharpened?
8.
So 8 goes first, because that's the order they gave us. So how many that are sharpened?
9.
9. Can I simplify those numbers?
No.
No. Could I make an equivalent ratio and say 16 to 18 is the same thing?
I
Yeah.
think so. I would think, yeah.
Yes, you can. All you're doing is multiplying those numbers by 2.
Exactly. All I'm doing is doubling those numbers. So
Wait,
proportionally, we have 2 equivalent ratios. So for example, 2 over 4 is equivalent to 4 over 8. They're equivalent ratios. And again, like Charity was talking about, I can just multiply times 2 to keep creating them.
Yeah.
So we want to use ratio tables to solve problems involving ratios. So on a school bus, we have 42 total students. The ratio of boys to girls is 3 to 4. So boys to girls is 3 to 4. How many girls are on the school bus? Well, I'm actually going to add in a third comparison. If we have boys to girls, I'm going to compare that to the total. So if there's 3 boys and 4 girls, then that means that there is 7 people total right there.
Yep.
A 3 table, boys, girls, and total. But they told me how many people are actually on the school bus.
42.
So 42 would go in which column of my table?
The total.
Good. And we work with ratios multiplicatively. So is there a multiplicative way I can get from 7 to 42?
Yeah, you multiply by, is it 6? I'm not sure. Let me just.
So if I do it for total, would I also do it for boys and girls?
Yes.
Yes. Then you can find out the number of.
So then how many boys were there?
18.
How many girls?
24.
What if I asked you how many more girls there were than boys?
Oh, subtract 24 by 18.
Right. So there was there was 6 more girls. Very good. Right, so we're gonna now use more ratio tables. So Miss Hardig is painting her bedroom to get the perfect shade of purple. She mixes 2 cups of red and 3 cups of blue paint. If Miss Hardig needs 12 cups of blue paint to paint her entire bedroom, how many cups of red paint will she need to make the perfect shade? How many total cups of red and blue does she need to paint her entire room? So they're asking us 2 questions. First, they're asking us cups of red, and then they're asking us total cups. So I was given the information that for every 2 cups of red, it takes how much blue?
3 cups.
3. Which means for this ratio, what would my total number of cups be right there?
5.
Okay. Well, it told me that I actually needed 12 cups of blue to paint my entire bedroom. So then how would I get from 3 to 12 multiplicatively?
I need to read.
Multiply by
Multiply by 4.
So then how many cups of red did I use?
8.
8, yeah.
And then Ethan, how many total?
20.
Good. Does this make sense to you guys?
Yes.
Yeah, it makes sense. I'm gonna have to mute myself for a little bit.
Okay. So then when it says how many cups did I need, or how many red cups did I need? I needed 8 red cups, and I needed a total of 20 cups. Carol needs 12 chocolates and 8 suckers for every 4 goodie bags at her birthday party. If she's making 10 goodie bags, how many chocolates and suckers does she need? So Charity, what are the 2 things that I'm comparing right here?
Chocolate and suckers.
Chocolate and suckers. And chocolate and suckers go together to make a what?
20.
What? If I'm putting chocolate and suckers into something, what am I making for this birthday party?
Oh, goodie bags. I
bags?
thought you were adding them together.
Didn't understand.
So it takes 12 chocolates and 8 suckers for how many goodie bags?
4.
Good. But I want to make how many?
10.
10. Okay. Well, can I get from 4 to 10 like the other problems? Because I was multiplying or dividing. Or is this going to take me an extra step?
I think it's gonna take us an extra step.
Okay. Can I divide to a number here that will let me multiply back up to 10?
2.
Yeah, 2.
So how did I get from 4 to 2?
You divide by 2. Big brains.
So then if I divide by 2 over here for suckers, how many suckers go into goodie bags?
4.
4.
And how many chocolates go into goodie bags?
6.
All right. So I know it takes 6 chocolates and 4 suckers for 2 goodie bags. Now, how can I get back to 10 goodie bags?
Multiply by 5.
So then how many suckers?
20.
That's a lot.
That is a lot.
It's not fair.
And then how many chocolates?
30? Wait, no. Yeah, 30.
So it took 30 chocolates and 10 suckers to make 10 goodie bags. Do I have any questions about that one?
No, that's pretty straightforward.
Okay.
Yeah.
All right, so now we have the fractions ones, which I know was a little challenging.
Oh,
So-
this.
Miss Cates is making 3 batches of lip glosses called Pink Sunset using the recipe shown below. Each batch contains a different total amount of gloss. So for 1 lip gloss, half of it is pink, a third is red, and a sixth is clear. Use the table below to show how much gloss you used for each batch of Pink Sunset lip gloss. So I was explaining it to Ethan yesterday in terms of like when you make cookies, sometimes you want to make more or less than what the recipe gives you. So you have to improvise. So for the first one, let's look at batch 1. I was given that they used one whole thing of clear. So they used one whole thing of clear right here, but they told me that individual recipe calls for only 1/6 of clear. Well, what did they multiply by to get to 1?
6.
Good. So they basically took the ingredients and said, okay, this is a ×6 situation. So then pink, if half of it was pink, well, I'm actually doing 1/2 times 6 now. So what is half of 6?
3.
So I'm actually using 3 of the pinks. And if it's 1/3 is red, but I need to multiply that by 6, what do I get?
Sorry, I'm trying to get all the stuff down so I can remember this whenever I do it.
2.
Very good. Ethan, can I move on to the next batch, or you want me to put it?
I'm still doing okay. So I have a question.
Yes.
Why did I decide to use 6 to multiply?
Because we were given that we use one whole of the clear. So
Okay.
one whole, we use one whole, but the recipe only called for 1/6. It takes 6 groups of 6 to get to one whole.
Yes. Okay.
That means that I need to use 6 groups of every other ingredient as well.
Will do. I got that. Thank you.
All right. So now we will move on to batch 2. So for batch 2, I was given red, where 1/3 of it is red. But they told me I'm actually using 1 and 1/3. Well, one whole breaks up into 3/3 plus that extra third, which is actually 4/3. If the recipe only called for 1/3 of it, how many of the recipe did I actually make? What's my times here?
Times 3? Or is it 4? No, times 4.
It'd be ×4. Because if the individual recipe called for 1/3 and we used 4/3, we actually did the original recipe ×4. So now if it's calling for 1/2 of pink in the original recipe, what do I need to multiply 1/2 by?
4.
And what do I get?
2.
Okay. And what does the original recipe call for clear?
Wait, how did I get 2 when I multiplied 4 by 1/2?
You're
Oh,
taking
1/2.
half plus 4.
Okay. Okay.
So then 1/6 is clear, but I need to multiply it by
4.
So I get 4/6, but can I simplify that?
Yes, to 2/3. 2/3.
Good. Are there any questions on this one?
No.
No.
Okay.
No.
So now the last one, we're told that we used 4 holes of pink, but it actually only tells me to use 1/2. Well, 4 breaks up into, how many 1/2s does it take to get to 4 holes?
8.
Yeah, 8.
Good. So it breaks up into 8 groups of 1/2. Which means that batch 3 is times what?
8. Gosh.
Good. So for red, if it originally calls for 1/3, and I multiply it by what?
8.
8. So I get 8/3. Well, we want to write this in our mixed number format. So I see that my numerator is bigger than my denominator. So I'm going to decompose this into 6/3 and an extra 2/3. Because I know that 6/3 is really just 2 and 2/3. Do you have questions on how I did that?
No, you just have a big brain.
Does it make sense though how I'm decomposing to the 6/3 and the 2/3?
Yes.
It makes sense. I understand it. It's just I don't know. I understand, but I don't understand it. It's like a mixed.
It's the same idea as saying 8 divided by 3. You have 2, you take away 6, you're left with 2, that's your remainder, and it comes up and you're left with 2/3.
Okay.
It's the same thing.
Okay.
So almost think of it like if you have something like 4/3, that breaks up into 3/3 plus an extra third. So really that's just 1 and 1/3.
Yeah.
Okay.
Right. So for clear, it calls for 1/6, but I need to multiply that by what?
8.
Right? So I get 8/6, which I know can simplify to 4/3. Is there a hole in there? 1 hole and 4/3?
Yes, there's 1 and 1/3 left.
Exactly. So then it takes 1 and 1/3, makes it clear. All right, any questions on the fractions?
No.
No.
All right, so I'm going to come back. I'm going to stop the recording.
That was another fast one.